Good morning, guys. I'm going to make a video presentation about how how to make this remaining cargo. And the vessel at present wrap is trimmed by the stern of 45 centimeters, and his updraft is 13.30, which is a summer draft. And he wants to make the departure maintain this updraft of 13.30 to summer draft as his departure drop. So he wants to maintain this updraft. So then we will load the remaining cargo, but we will maintain the drop up of 13.30. So let's start, guys. Okay. The problem says MB Max Panama is loading to its maximum summer drop in salt water. Okay, at birth. At the near completion of loading, drop forward is 12.85 and drop up reaches the summer drop of 13.30. Okay, meaning is drop up of 13.30 meters is is I'm sorry is why have like this like this. Okay, find the remaining cargo to load and maintain the drop up of 13.30 meters. Meaning we maintain this one. This is your summer drop, which is this one, guys. I'll show you the summer drop. Go to the capacity table. And the summer drop is 13.25 or 13.30. Okay? So that is the summer drop. Now, proceed to the problem. The present drop is 12.85 forward and up drop is 13.30 and trim is 0.45. So we put it in the program. So forward is 12.85 and up drop is 13.30, which is the summer drop, and its mean drop is 13.80. So, for example, the upon reaching this drop, the chief officer, the foreman, advises the chief officer that he will stop loading and he will be waiting for the remaining cargo to load. So when the since the pilot, the draft surveyor is on board and is waiting for the operations to stop. So the chief officer and the draft surveyor make a reading around the vessel, and they both agree that forward drop was 12.85 and up drop is 13.30, which is the summer drop, and their actual mid port is 13.08 and the mid starboard is 13.08 and the main drop is 13.08 and the trim is 0.45. So they both agree on this one, and our sailing drop is 13.30. Okay, you can put 13.30 here. This is our sailing drop. Okay, which means your sinkage is 22 centimeters from. So it will take 22 centimeters from your mid drop to reach this departure drop of 13.30. Okay, it will take 22 centimeters. Now, there's another way of getting this 22 centimeters or sinkage. That's we call sinkage. Okay, our okay, I just continue this one first. When you click this one, we convert this sinkage into metric tons. So how do we convert this into metric tons? So you click this one. The sinkage formula would be weight. Okay, sinkage. What is the weight? Weight is to get this value of recommended cargo to load is click this one, K8, which is the sinkage, letter A, K, and 8, which is the sinkage, times your M3. It is the TPC of your departure draft times 100. Okay. Take note, guys, when you put your departure draft of 13.30, you interpolate the TPC. Once you have interpolated the TPC, it will be 6445. Let's put it here. So we just continue the formula to get the value of the recommended cargo to load is K8, which is sinkage, times M3, which is the TPC of your departure draft, times 100. That will be, you will get 14.17.9. So I'll try to take out this out, and we'll try to apply the mathematical equation. So you put equals, then you click your sinkage of 0.22. There you go. Multiply by your MTC from your sailing draft of 13.30. Click this one. Then you multiply it by 100. Okay, multiply by 100 and you will get 1417. Okay, so this is the recommended cargo to load to reach the 13.30 departure draft. You see this arrow, you scroll down and make this a round up of 1418. Okay, so when you press this one, what happens if you load 1418? The results after loading, your mid draft will be 13.30, which is exactly the same with your final mid draft, and your sinkage is 22, which is the same with this your sinkage. Now, there's another way of getting the sinkage. Since you know already your remaining cargo to load is 1418, if you run it up, so you put here 1418, okay? 1418. And your TPC of your initial draft is 6434. So that is 6434 there. After you put this one, these two figures, your remaining cargo to load with 1418 divided by your TPC, that will be 22 centimeters. Okay, divided by 100, that will be 0.222 meters. Okay, since your initial draft is 13.08, you add your sinkage of 0.22, then your departure draft will be 13.30, which is exactly the same with this one. Okay, so with this figure of your initial draft, you take out your LCF, NTC, and TPC. Okay, that is already automatic in your program. Then we know already the remaining cargo to load. Then it says here, then go to trim holes 2, which is this one, trim 2 holes. Then you go up. Take note that the remaining cargo is already put here. So this is what we call the trimming with 2 holes. Okay, and you have here your initial drop forward and up, and your main drop and your trim and your MTC, LCF, and your TPC. Likewise, your remaining cargo to hold is 1418 here, which is actual cargo to load for trimming. Then let's say you're going to load in hold number 1 and hold number 7. Okay. So how much are we going to load in hold number 1 and number 7? Scroll down, and let's say you have no trim because you want to maintain the drop up of 13.30. That's why you have to put 0 trim, so that you will maintain the drop up of 13. This is the summer drop. So you want to maintain this figure of 13.30, so you better make your vessel 0 trim. Okay, so now, since you have already put the 0 trim here, your target trim of 0, and how much are we going to load in hold number 1? So number 1 and number 7. In hold number 1, it says you have to load 999. So you put here 899. I'm sorry, 899. Then number 7 would be 519. 519 if you round it up, and your departure drop would be forward will be 13.30, updraft will be 13.30. You have 0 trim, and your main is 13.30, and you have maintained your updraft of 13.30, which is the summer drop, and your deflection is 0. Okay, where did I get this one? Mid drop, just put this equals, go to form number 6, and you click this one. When you put this one, you click this one, and there he goes, and your main drop is this one. So you put equals here, and what will be your main drop, and enter. So you have a 0 deflection here. Take note, guys, of the cargo we load in hold number 1 and number 7. That's 899 and 519. You go back to form 6. Okay, go back to form 6. Scroll down, and here in number 1, you will load 899 and 7 hold 519. So hold number 1, 899, and number 7, 519. You apply the LCG, and your final departure would be forward will be 13.30, updraft will be 13.30, 0 trim, and main is 13.30 almost. So it's an even kill. Okay. Then we go now to the trim table. Okay, this is your trim table. Take note also that your remaining cargo to load is already applied here. So with your hold number 1 and number 7, and the amount to be loaded in number 1 of 899 and 7 of 519. All you have to do is get the forward up correction of hold number 1 and forward up correction of hold number 7. So we go to the trimming table. So this is your name of your vessel. You have here draft of 2 meters, 4, 5 until you reach 14. This should be your hold number 1 of forward and up correction. And so with number 7, hold number 7, forward up correction, and this is your 4 meters drop. Since your departure drop is 13.30, so we will use this 13 drop. So 13 meters drop, so 13.30, so I highlight this one. 0. Okay, so I highlighted and highlight this one. Okay, then we go to hole number 7. I'm sorry. Almost 13 meters, 13.3. So this one, we use this one. Make this, make this. And take out the highlight. And this one, number 7, forward and up. Make this highlight red and black color. Okay. In hole number 1, forward correction is 6 meters. 60. So you apply the correction. Apply the correction. You have your 6. And up correction, how much? Up correction is, up correction is negative 29. Negative 29. Then you put here negative 29, okay? And in number 7, forward correction. Number 7, this is number 7. Forward correction is negative 18. Negative 18. There you have. And up correction is 4.8 in up. Up correction is 4.9. So you put here 4.9. Okay. And now you will see your departure drop will be, your up drop is 13.29 and your mid is 13.29 and your mid is 30, 0 trim. But we will adjust this up. So from here, this is your up correction of number 7. We'll adjust this one. What happens if we put, let's say 1, increase it, okay, or make it 2. Take note of your up drop, and your trim, okay. So press enter. So the mean now is 30, increase to 30. And take note also of your deflection. So from 9.2, we put it to 9.3. Okay. Then they are now even kill. Forward is 19.30, up is 13.30, mean is 13.30, mid is 13.30. Your 0 trim and your deflection is 0. Okay? So you are now even kill. Now there's another way of doing this trim table is that first you want to load in hold number 7 so that you will have a good trim. So in number 7, you load 519 and your forward correction is negative 18 and up correction is 4.93. So once you finish loading number 7 and number 1, your amount to load in number 1 is 899, your forward correction is 6, and your up correction is negative 2.9, okay? This is your initial drop of 12.85 and 13.30, which is your initial drop here. Okay, initial drop, okay. And once you have completed your amount of cargo 519 and hold number 7, this will be the initial departure drop. Initial drop of 12.76 forward and up drop will be 13.56. So carry this down, then you are now going to load in hold number 1 with 899 metric tons. Once completed, your final drop will be forward will be 13.30, up drop will be 13.30, you have 0 trim and main is 13.30 and your deflection is 0. Okay, that is trim table. Now we go now to the last one, form number 7, which is, it says here, how to find drop and trim when handling weights involving large changes in mean drop. Okay, according to the problem that at birth, the density at birth when loading is salt water. Okay, when you say salt water, that is 1.025. This is your initial drop of 12.85 and up drop of 13.30. Okay, then you apply how much cargo you're going to load in number 1 and number 7. So in number 1, okay, you will load about 899. So you put here 899 and number 7 will be 519. Number 7 is 519. Then put here 519. 519. Okay? And what will be your departure drop? And your, before completion or loading, you put also your density of 1.025. And this will be your main drop of 13.296, which is almost 13.30. And this is now your departure drop. Forward will be 13.30. Up drop is 13.29. And your main drop is 13.30. You have zero trim. And your deflection is 0.19. Okay. This is updraft is 13.29 because of the mathematical equation. But the true draft you will get is forward 13.30, updraft is 13.30, and they are even kill. Okay, so with your trim holds 2, you will also get the same results, even kill, and your trim table is also even kill. And so with the another solution of trim table is also even kill. Okay, just only this form 7. There's a little difference because of the mathematical equation carried out by this program. Okay, so let's go now to the manual computation. So you are now forward is 12.85 and up is 13.30 with a trim of 0.45. So you are trimmed by the stern. This is how it looks like when you are trimmed by the stern. So your target drop is even kill or 0 centimeters and your present trim is 45 centimeters. So this is the situation of your vessel when you are trimmed by the stern of 45 centimeters. Okay? Proceed to the program. And your main drop is 13.08. This is the recommended cargo to load 1418. But I will show you how to get this figure. Okay, so we go down. Then from your mid drop of 13.08, you will take your MTC, LCF, and TPC. So this is from your, okay, let's just do it this one. Okay. So from your mid initial drop, you have your TPC, MTC of LCF, and TPC. So we go to the, let's say go to the hydrostatic table. Okay. You put here your main drop of 13.30, 13.30, and what will be your, I'm sorry, what will be your MTC is 979.19. Okay. That is 330. Okay. This is 13.08. Sorry. I'm sorry. Your main drop of 13.08. Okay. So 13.08, you go to the program. 13.08, your TPC is 6460. 6460. That will be 6460. 1308. Check it again. 1308. 13.08. Your 13.08, is that correct? 1308. Main drop. 1308. Your TPC, better this one. And your main draft is 1308. Put here 1308. Hydrostatic table. This one. 13.075, almost 1308. Your TPC is 6434. 6434. I'm sorry. 6434. 6434. And your LCF is 017. LCF is 017 and MTC is 979.19. 979.19. 979.13. It should be 7.19. Okay, put this 19. Put this 19. Okay. Okay. Then why is it? Take note, guys. I will equals sum, open, click, plus, click the up drop, close, divide by 2, and 3. That should be 0.05, which is what you got from here. Okay, 13.05. That's why you have this figure. Just want to show why we got this figure. Okay, then go down, correct. I'll show you this one. No, the program, number 2, and this is the MTC, LCF, and you have the same figures here. Okay, then we go to number 3, which is correct the LCG of uphold to this distance from LCF. So your LCG of number 7 is 6632. Number 7, okay, number 7 is 6632 LCG, okay? And your LCF is 0.17. Same sign, subtract. They are all positive, so you subtract, that will be 6615. Then we go to number 4. What is the distance between hole number 7 and number 1? So the LCG of 7 is 66432 and hole number 1 is negative 8698, which is number 1, negative 8698, the LCG, okay? It says here, different name, add. So they have different name, you add, the total will be 153.30. That is the distance between hole, okay? And change of trim. Change of trim is your final trim minus initial trim, or the side trim minus your present trim. So your final trim will be 0 because you want to have the departure in even keel, and your initial trim is 45 centimeters, which is this one. Okay. So your change of trim is negative 45. You are trimmed by the stern. Okay. Trimmed by the stern. I will tell you why it is negative, okay, later. Then some information, your LPP, ship's LPP is 215, which is this one. LPP is 215. Your LCF is 17. Okay, 17. I'm sorry, 17 LCF. And your LPP, one half of LPP is, because your LPP is 215, one half of 215 is 107.5. Okay, you can do it like this. Equals 215 divide 2, and that will be, I'm sorry, equals LPP divide 2, that will be y. What is equals sum 215 divide 2. That will be how much? 0. Numbers. Oh, I put it like this. Like this. 2. Bakit y? Equals 215 divide 2 equals, it should be 215 215 divide 2, 107.5. Okay, I don't know why it doesn't answer this one correctly, but one half of 215 is 107.5, and your change of trim is negative 45. Okay, now we will compute for the how much we're going to load in hold, forward, hold, and forward part, forward and up. Forward, this will be hold number 1. Okay, 1. Up part, this will be, sorry, this will be, okay, this will be hold 7. Okay, take note, this will be hold 7, and forward part will be hold number 1. Okay, so you will not get confused. Okay, to get the value of hold number 1, forward, this is the formula, distance up hold from CF times remaining cargo to load minus your change of trim times MTC times 100. Okay, so I already transposed this one. Your distance from uphold from CF is 6615. 6615. This one is 6615, and remaining cargo to load is 1418. Okay, 1418, which is this one. Remaining cargo to load is 1418. Okay, minus your change of trim, which is change of trim is 45. Okay, or this one, change of trim times your MTC of 979.19. This will be 179.19. Okay, just this. Make it accurate. Okay. And your distance between hold is 1350. Distance between hold is 1350, which is from 7 hold and number 1. Okay. And the value of this equation is 91980.7, and the value of this equation is negative 4406, and you minus these two figures, and the answer would be 137.86155 over your distance between hold is 899 forward, which is hold number 1. So hold number 1 is 899. Okay, that is going to load in hold number 1. Now in find weight up, or in weight hold number 7, the formula is remaining cargo minus your weight forward. So your remaining cargo to load is 1418. 1418. It should be 1418. Okay. 1418. I'm sorry. What 1418? This is take out. 1418, which is remaining cargo to load is 1418. Okay. Minus your weight forward, which is 899, and your weight in hold number 7 to load is 1519, which is this one, 519. Okay. Or you go to your 519. Trim holds 2. Then, once you completed that one, this is another formula for how to find the sinkage, which is your weight of 1418 over your TPC over your 100, your sinkage is 22, which is, sorry, which is this one, your sinkage. Okay. The simplest way is your departure drop minus your mid drop, then you will get 22. Okay. That is the simplest way to get the sinkage. But the other formula would be this one. Weight, which is 1418 over TPC. Your TPC is 6430 and times 100. Then you will have 22 centimeters. Okay. The same as you get there. And sinkage, and there's another formula here. Your departure of drop of 1330 minus your present drop or your mid drop, the your sinkage should be 0.22. Okay, the same. Then go down, apply this, how to get the departure drop. This is the same one. Number 2, it is the same. The same with this equation and also this one. Okay, this will also be the same. But anyway, manually, let's apply the manual operation. So your initial drop forward is 12.85 and up drop is 13.30, which is this one. Okay, just apply your forward and up drop. So your forward and up drop is this one. Then you apply your sinkage, which is 22 centimeters, which is this one, and this one. Then I will explain to you why we apply. Okay. you are going to put the weight of 1418, okay? So when you put the weight here on number 7 and number 1, the vessel will sink, okay? Will sink. That's why you have a sinkage of 22 centimeters. So from your present drop of 12.85 and 13.30, you put the weight of 1418 into your vessel, then you will sink. The vessel will sink. That's why when you add your sinkage of 22.22 centimeters at forward and up, then your new drop due to sinkage will be 13.07. You add this one, and you add this one, that will be 13.5. Okay? 13.52. Because of the sinkage that of this weight of cargo that you're going to load in the vessel. Okay? Now, then you apply now the change of drop. How do you get the change of drop? So change of drop is this one. Change of drop forward is 1 half LPP plus LCF over LPP times your change of trim. So while ago your 1 half of LPP which 215, 1 half of 215 is 107.5, okay? Plus, according to the formula, plus your LCF. What is your LCF? LCF is 0.17, okay? 0.17 over your LPP of 215 and your change of trim of negative 0.45, 0.45, okay? You add together this one, 107.5 plus 0.17, that will be 107.65 over 215 times your change of trim. You divide this one and the value will be 0.55, 0.05008 times your change of trim, then your change of drop forward will be 0.23, okay? Now, the formula to get the change of drop up is your change of trim, which is 0.45 negative, minus your change of drop forward, which is negative 23. Then your change of drop up will be negative 22. So take note of 23 and 22, all negative. Then apply that to your equation. So from your new drop due to sinkage, you apply the change of drop forward, which is 23. Okay, 23 and up is 22. So why? Take note that you will add a number. You will add a number in the forward and up. You will minus. So 13.52 minus 0.22, that will be 13.30. 13.07 plus of 0.23, that will be 13.30, and even kill. Mean drop is 0 trim. Then I'll see you because you want to make this vessel to even kill in this situation. Okay, so the tendency of this forward or up, a part of the vessel is to go up, and this one to go down. Again, this up part will go up, and this will go down to have an even kill situation like this one. Okay, did you see? This one went down, this one go up. Okay, now where are we now? That's why you up part you deduct, so we'll go up, less drop here, then that is minus, this one is forward, you plus because it will shake down, and up drop will go up. Okay, Now, the next thing to take note, this, since you are now even keel, take note of the main drop. Main drop is 13.30. So 13.0, uh, what is the LCB of 13.0? Okay, this is the main drop, departure drop. We go to the hydrostatic table, put here 13.0 LCB. Okay, put this 13.0, this one 13.0. Your main drop of 13.0, 13.0. LCB is negative 63, okay? Negative 663. Negative is, LCB is at main drop of 13.30. The LCB is negative 663, okay? And what is the LCG of this drop of 13.30? Investigate, guys. Let, let's read this one. On an even keel vessel, the role of longitudinal center of gravity, which is LCG, and the longitudinal center of buoyancy, which is LCB, is that they must be vertically aligned. Okay, so what does it means? Let's go to the drawing. Since your LCB is negative 63, okay, negative 63, from your amidship, this is your amidship, okay, this one. You will measure from amidship going forward, that is negative, and amidship measure going from amidship going backward, that is positive. Since your LCB is negative 63, so you measure from amidship going to 6.3, that will be your LBC. So your LBC is negative 63 from this one, okay? That is your LBC. Now, let's read again the explanation. While LCB is, they must be vertically aligned. Meaning, what you say vertically aligned is that in a even keel situation, your LCG, this one, going down, and your LCB, this should be vertically aligned. So they are in even keel. So there's no trim here because they are vertically aligned. So LCB is in one line with your LCG. So they are vertically aligned, which means there's no trim. Okay, there's no trim. That is what it meant here. Okay. So they must be vertically aligned. LCG represents the combined center of weight of the entire vessel. So LCG of the weight of the entire vessel will go down, will sink. Okay? While the LCB is the center of the water volume where the force of buoyancy acts. So when you say buoyancy, the water pushes the vessel upward. So they are in one line, there will be no trim because they must be vertically aligned. Okay, this because they are vertically aligned. The weight of the entire vessel will push the vessel downward to sink, and the buoyancy of the water will push the vessel upward. So they are in one line, so there will be no trim. Okay, that's what it means there. And go back to the figure, back to the explanation. For the ship to float on even keel without trim, meaning no trim or even keel, the LCG and LCB must be positioned on the same vertical line to maintain equilibrium. So they must be in the same position on a vertical line. So there is no trim here because it's even keel. That is what it meant by this explanation. Okay, guys? Okay. I made an arrow here because we are in the initial we are trimmed by the stern of 45 centimeters. So this up part will go up. That's why you're in a clockwise direction, and this one will be clockwise also because this will go down because just like a seesaw, when this goes up, this one goes down. Since you are trimmed by the stern of 45 centimeters, they have to go up to have even keel, and this will go down. Okay, that's why your LCG, which is measured from amidship going forward, which is negative of negative 63, so they are now in a vertical line, and there is no trim. Okay, that is what it meant there. So forward is 13.30, up is 13.30, main is 13.30, trim is 0, and they are now even keel, okay, according to our equation here. Now this what you call this message or this what you call the theme does not apply. If LCG is above of LCB, then you are trimmed by the stern. If LCB is trimmed by the LCG is forward of LCB, you are trimmed by the head. If LCG is above of LCB, then you are trimmed by the stern. But in this situation, the LCG is not behind of LCB, and LCG is not forward of LCB, but he is in a vertical line of LCG and LCB. So that is why it is at even keel situation. So this one does not apply. So that's it, guys. I think I have already explained to you things. Okay, this one. And this in for number 7, you will apply here the density upon uh, taking the initial draft survey and your final draft survey. You will also have your density 1.025. It is also the same here in whole numbers form 6. Okay, form number 6, go up. So when you take your initial draft, you put your density of 1.025. Okay, 25. And on final draft survey, the surveyor will also take its density of 1.025. Okay, so the vessel under operation loading is in the density 1.025. Then you will get the final departure of even keel of 13.30. Okay, that is also the same here. See, you put your initial density here, put your final density here, and your departure drop will be almost even keel of 13.30. Okay, with the same cargo that you're going to load in hold number 1 and hold number 7. So that's it, guys. I hope you like this video. If you like, please click the like button and subscribe. And please don't forget to click the notification bell. Thanks for watching. Have a good day.